Hi guys, and welcome back to Wade's Workshop. And a bit of a bang on the elbow. Let's shut that drawer. Should we try that again? Hi guys, and welcome back to Wade's Workshop. Okay, right. So, a little update report on the power feeds and what have you. It's getting a bit long-winded. I haven't forgotten, I am going to put up the list of all the parts that I've bought on the websites, what have you. Basically a set of links with a description what they are. Probably on the next video, but we'll see. I may put it up in the description of this one. So I haven't forgotten, guys. Okay, so I needed a couple of screws, M3 by 16 countersinks to screw the little micro switch down in the little box that we were making in the previous episode. Zorro again, box of screws, 200. I needed two, but you never know. Some countersink screws, I bought them a little longer than I actually needed, but they're not too long for the job. But you can always cut them down, you can't make them longer. So I bought them 16mm long. So a box of 200 of those. While I was on the website, Zorro, I decided to buy myself a new set of digital calipers. Now, I've gone for Moore and Wright, a set of digital calipers from Moore and Wright. Now, why did I go Moore and Wright? Well, good quality, great name. Not Mitutoyo standard, I wouldn't have thought, but they're still very good quality ones. I had a 10% discount code because I buy off Zorro a fair bit. So, you know, you get the emails with a discount code, come back and buy some stuff. So I decided while I had the discount code to buy myself a replacement set of calipers. So let me just explain. I've got my set of clunkers, which I use all the time, which are a Sealy one. They're, you know, they're not the cheap Chinese ones. These ones, I believe, they're about £30 a set, but they are good quality or medium quality. And I use them all around the shop all the time as basically a set of clunkers. So if they break, get abused, what have you, it's not the end of the world. I wanted something for general use around the workshop. That, you know, general use again, but not really expensive ones that are going to get worn out, shattered, all the rest of it. So that's why I went with the Moore and Wright. And I don't show these very often because I don't use them much. I have got my set of Mitutoyos, which keep for best. They don't get abused, they don't get, you know, they're not getting worn out, and they're kept, you know, for when I need to measure something accurately with the calipers. So yeah, I haven't actually opened the box for these yet. I know they're blue. Yeah, and as you can see, well, I'll open it on camera. Need to put the battery in. So yeah, a nice set of Moore and Wright, which are a good quality set and will be used around the workshop on a more regular basis, which means I haven't got to get the Mitutoyo ones out all the time. And these, let's say, accuracy value, these are probably about a 5. We'll call these a 9. And the Mitutoyos, we're going to give them a 10 out of 10. But price-wise, I think they're normally £59 for these. And I think I got them obviously for like 53, something like that with a discount. So yeah, that's a new set of calipers. Oh, and I'm always wearing these things out, but I bought a better one this time, not a Chinese one. Automatic centre pop. It's a Draper one, not one of those sort of generic Chinese ones that you can get for £1 or so. I think that was a £5 again with a discount, you know, £4.50. So yeah, a little bit of shopping. We'll move on. I've completed the little limit switch box and done a bit more there, so we'll show you that next. I've just bolted the block on in place, and the original little sort of finger that was on here had a step cut in the back of it to stop. As you can imagine, this bottom part is clamped to the carriage, and we don't want this rubbing on the table. So just a little measurement, it's about 22. If I machine a step in the back of it, 23mm, only about a ½ mil deep, we should be absolutely fine. So I'm going to whip it back off and machine that step. So I've just measured the original. There's actually a 1mm step on the original. So I'm just going back and forth on this, 0.25 at a time. That's 11.5mm in from the edge. And I'm 0.1 off depth, so I'll move it back over in a minute to the 23 mark or 22.9, come back down, and then we'll finish past it with 0.1 cuts. Again, using the power feed, and it's like an absolute mirror, that finish on there. I don't know how well it shows, but yeah, it's pretty hunky-dory. So I'll just come back across, winding in Y to the 22. In fact, I'll drop back off to 0.25 deep. Why don't I do that on camera? Let's just fast traverse. Well, we call it fast traverse. So the next spot is going to be 23 on my DRO, or 22.9, 12mm cutter, so let's hope we'll do 11.5 each way. Happy days. So that's a 0.25 cut now. 0.1 off the shoulder. So go back and forth. It's probably feed faster than that. There we go. And work it over the top of the camera here. Travel off the end, increase the cut to 0.5, back the other way. You get the picture. So I cut the holes in the top face now. I spotted them with a 3mm spotting drill, 2.5mm drill for 4 little M3 screws. I haven't got the M3 screws I need. I have for these 4, but not for the switch. I have got some on order. Bag of 200 from Zorro again. I've ordered a few other little bits and pieces from Zorro while I was at it, but I'll show that when they arrive. Let me just pull the parallel out from under there. Okay, that should do me. Okay, I drilled them right through the full 19mm because nobody wants to tap a blind M3 hole. And I'll clear the backs out probably 10mm deep, so I'm not tapping all the way down through as well. So just flip the block over the other way, and from this space here I'm going 11mm deep, but still the same reading at 12 on my scale. So I basically touched off on that top face, drilled down 12mm, which is, where are we? There, leaves me about 7mm of the 2.5mm for tapping, so more than enough for the threads. So that's those 4 done. Little countersink on those now, or countersink, yes, countersink. So get my little countersinking bit. I have a small one here somewhere. There we go. I think that will just fit. I think that's a 6mm shank. Yes, it will fit my chuck. And we'll just countersink those holes. You're not doing anything on the back edge, it's just, what would we call it, burr removal really. And do those 2 as well. I did do them with the Noga, but while I've got the countersinking bit up, I just as well do them. I'll do these 2 as well. They're the tapped holes for the micro switch. So they're all countersink nicely, or countersunk nicely, I should say. Right, so I need to tap these 4 holes now. Okay, so I'm just moving on to the little brass stops now, which are going to go inside the switch. I'm just going to put them with that flat I machined earlier facing down. Right, so I've got a little 3mm spot drill again. I've done the first one, it's already got its hole in. Let me just show. There. So for the second one, I'm the same distance off the back edge of the vise, so I haven't got to move that. I just want a rough and ready way of finding the centre. So if I put a rule on top, bring that drill down, you can see that the rule is down on this side. So I need to move the vise this way. So let me just take a bit of pressure off. It's coming up a bit more, a little bit much. Let me just explain. If I come with the drill right off this side, I'm coming down on this space, and the clamping area will be more sort of in this orientation. So I'm high this end, so I need to come this way a bit more. Take the weight off. There we are. Now, as you can see, the rule has leveled out, so the clamping force between the tip of the drill is on a level surface or not offset. It's going to be close enough for what I'm looking for. I'll just lock everything off there. Mark a little spot with a spotting drill. It's quick, it's rough and ready. It'll get you, within a few thou really. Very similar to the trick for aligning the tailstock on a lathe. Making sure it's not offset. You put the rule between two centres and see which way it's leaning. Exactly the same trick, but just for finding the centre of a radius. So just drill that down through. Okay, and again I'm going to tap these by hand. So out with the drill, and they're ready now for some tiny little M3 grub screws. I think I've got some M3 by 4mm grub screws. So I'll tap them first, and then we've got space for some grub screws. It'll just get it started nice and square. Looks good. Oh, that's my box of grub screws falling off the shelf behind. Nice and gently. That's it. Back out with a tap. Okay, so a little 1.5mm Allen key. Oh, I've got my little grub screw at the ready. Do not drop it. 8. Do not drop it, because it will disappear in amongst the swarf. Hold it in position. There we are. Pop him in the hole. And there's the other one I prepared earlier. So I did the first one off camera, as you do. So that's the two grub screws that are going to hold these sleeves or collars onto the shaft. I do have to do a little modification on one of them just to make it ride up the switch easier, but that's simple enough. And I may have to take a little bit off the front face to stop them fouling. In fact, I believe my depth of the pocket was, these are just off the bottom, the pocket was 11mm deep. These are 11.6, so they are going to have, let's say, a mil taken off the top. So there we are. Finishing pass. That's a mil off the top of it. So we'll now sit on the shaft and won't rub on the lid. When we put the little lid on the box, it won't rub on the lid. It's dropping the top profile down. So that's the first one done. Do the same to the second one. I'll just pop that out. I've dropped the grub screw down below surface. A little brush, just get the detritus out of the hole. So the grub screw is dropped right down into the hole. Well, certainly more than a mil down into the hole. It's still not sticking out into the bore. So the little short grub screws I've got are a perfect length. Let's just drop a bit of a cut off that. That's 0.5mm cut. That's a bit heavy for a tiny little thing holding in the vise. I'll do 2.25 cuts. There we are. Wow. That's 0.8. Let that run off the far edge, come back, 0.2 cut. There we are, that's both of them reduced down with a flat on each side and a grub screw in the top face so I can get at it to adjust it. Happy days. Job's done. I'm just going to pop the cover off this little box. You can see the gubbins inside. The gubbins, well, you know, the innards. Right, I can just swing that round there. So, limit switch in place. The little rod with its two stops, I have put a couple of undercuts in the right place on the shaft, so these grub screws sit down in the undercuts so they can't move or slide. And as you can see, if I push on this side, works the limit switch. Exactly the same on that side. Limit switch is in, wires soldered on. Good old Gorilla Glue, epoxy glue in here holding the end of the little trunking in place, and that goes down through a hole in the bench. I'll show you that. So yeah, the cable basically comes from the switch and down through a hole in the bench, which is going down to the control box. And again, that's that Gorilla Glue, so it's not going anywhere. The two cables run down inside this little plastic trunking. So I've just pulled one of the stop blocks over into the position where it should be, and as you can see, what will happen, the stop block will come across, and there I heard it click inside, and that will shut off or kill the enable line to the motor. I can wind it back off a couple of turns, switch direction, and it will go back the other way. It's literally just a couple of turns off the switch. So that's the point where it would die. I'd only have to wind a half turn, it would be re-enabled, and I could go back the other way. So I've had the control box out, back on the bench here. I've actually, while I'm at it, while I've got it off, I'm fitting the second, or I have fitted the second stepper driver, the second control board up the top here, for the Z-axis speed, which is going to be the next sort of stage of it, and connected up some of the wiring for that, what's needed for now. I've just removed the enable wire for this, what is it, the X-axis, and this wire, basically, which normally goes in here in a little hole in the board, the enable wire, that's going to be connected up through a new gland which I put in the top, where this cable from the little limit switch is going to come in through here. Basically one wire joined onto the enable line. This is the enable line that comes back from the switch on the mill, the on-off switch on the mill. So it'll basically carry on back out to the mill again via the little switch and back out down here and onto the stepper motor controller. So that basically will replicate, when it hits my limit switch in the center of the mill, it'll replicate turning it off. So I made a bit of a mistake on my wiring. I suppose it's been a while since I connected up the original bit, and as it stood originally, this being the signal generator and this being the stepper motor controller, basically you've got a signal from here onto the controller via the on-off switch. That's fine, and this is shown in the on position. So if the circuit is broken at any time between this and this, the stepper controller, if the signal is broken, it's in the on position, as I've shown here, on. And I was thinking the other way around. Okay, so what I've done is set this up like this in parallel, basically daisy chained to two switches. So no matter what I did, even if I turned the way I had the limit switch set up, even if I turned the power off without pushing the limit switch, the thing would run. If I switched the limit switch, it would still run if this was in the off position, which I was thinking broken circuit off, but it's actually made circuit is off. Okay, so now knowing what we've got, when I was switching this off, this is a third circuit, with that limit switch not pushed, I was basically having a broken circuit and it would still be on because I was breaking the signal. So even if wiring up in parallel like this, or in series I should say, whichever one is switched off on or off, it would never stop unless you physically push the limit switch. So I had my limit switch wired up wrongly to start with. So I had to change the limit switch around. I'll show you that, so that it was permanently made on the switch, or in the off position, or permanently in the on position, and then when the limit switch was pushed, it then made the signal. So this would be on with the circuit broken with the limit switch, and then when you push the limit switch, it would make the circuit. So yeah, I had to cobble around with the limit switch. But as it turns out, what I should have done is put them in parallel rather than in series. So this being the on-off switch, this being the limit switch. So whichever one is pushed, it'll make the signal to the stepper controller and stop it. So whichever one is pushed. So if this is off, you can imagine broken circuit here. That would switch the machine on. They would both be normally open. So that would then run. And whichever one is pushed, whether that be the limit switch or the on-off switch turned off, the signal would come through. So that's the way I've got it now. I've rewired the bottom end bit. I've changed the limit switch around. I'll show you that. So as you can see, with the addition of a few new springs, that the micro switch is permanently a broken signal. And then when I push the switch, that makes up and makes the signal, which switches it off. And exactly the same in the opposite direction. So I'll put the cover back on and show you this in operation. So I've just brought my two stops in quite close to save on a bit of time. So if I'm traveling in this direction, hold on, let me just turn the power on to the power. Right, okay, so if I turn the power on, off it goes, reaches the limit switch and switches off. Now to travel the other way, I'll just switch off on the main switch, reverse direction, turn half a turn on the handle, and we're off the other way again. And stop. If I just change direction and wind, just as I start winding, it'll take off in the other direction automatically. So again, changing my directional switch, wind the hand wheel, off it goes. And we're talking half a turn of the hand wheel and it's gone. Back the other way. Okay, I don't want it to reciprocate. I could have set it up to reciprocate back and forth against the stops. Didn't want to do that. So swap direction, wind the handle, switch gets closed circuit again, and off it goes. And I can switch the power on and off at any time. Switch the power off, change direction, wind a bit, switch the power on, and away to go. So the limit switch is working. Eventually. Took me a couple of attempts to figure it out, but I've got there and I've got a spare spring and a spare stop. But never mind, we got it sorted in the end. So just as a bit of fun, just want to see how accurately it stops against that limit switch. So we're going back. We're in millimeters here. Yeah, half a hundredth. So we'll go back the other way. Back onto the stop again. Half a hundredth. Let's see. Well, consistently the same spot. Let me just put X to 0. Let's see if we can hold 0. I don't know. Here we go against stop. 0. Come back to it. Yeah, well, I think we're accurately holding perhaps half a hundredth. Happy days. So I know that those stops are pretty accurate when it hits the limit switch. Might be useful for repetitive jobs, for travelling set distances. Yeah, great fun. So moving forward with the Z power feed, I've got 4 bolts here, which I could mount a piece of aluminium onto, no problem at all, to, you know, maybe 4 standoffs and a stepper motor here somewhere. Belt drive again, fit a belt onto the back of the pulley. I'm going to put a sort of plastic enclosed on-off switch here. I think I know the sort I want. Basically a big sort of like an outdoor light switch on and off. And a directional switch on the end, but perhaps another one of these toggle switches. So knowing what I know now, it's going to be 4 wires from this switch down to the control box underneath, which will basically, you know, set the direction or the enable on those on the little box, and then 4 wires from the stepper controller back up to the motor here, much the same as I did on the table, or although I use many more wires to come into the same box, but 4 wires up to the motor, 4 wires up to the switch, probably bring them all up in one loom, and yeah, we can set that one up. So my next sort of mini project on here, other than making some stops for the table, is going to be to put some make up some aluminium bracketry for the motor and all here, run the cabling through. Again, same pulley setup, same set of pulleys, and we'll have a feed on the head. So just showing the setup as a whole. Motor, hand wheel here, all the gubbins in here, belt drive as you see. If I switch it on, what have I done? I'm against the stop. Right, so I can travel in this direction. I've got my vary speed down here. It'll go down until it hits the limit switch. Any second now. I should have sped up a little. Tables hit my limit switch, obviously. When they're in this position where they are down by the switch, it just saves a bit of time for this setup, but they could be anywhere back here. I will set another block in here, which is the maximum travel, so that we're not crashing the table out against its stop. So there'll be a stop here, and then when I bring this stop back, it'll be the correct distance for the maximum travel at the table, and the same the other end, so that I can't inadvertently, by moving my little stops here, over travel the table. They'll come back against something fixed on the bed, which will never move once they're in place. So yeah, if I want to swap direction, back the other way, wind off the stop just a little bit, back that way, I'll hit the stop, back that way, I can switch it off, just wind off the stop, switch it on again, or I can basically hand wind it off the stop, change direction, hand wind it off the stop. I haven't changed direction, have I? Yeah. Go the other way. This handle rattles. Against the stop. How much is it? Let's have a look. How much of a turn to come off that limit switch? Let's see, it should engage itself. There you go. Probably a third of a turn. So no great inconvenience having to wind it off the limit switch. Yeah. Really happy with that. I think I better put the cover back on that box. So something that's been suggested to me, I'm running the power feed setup on a separate power supply to the mill, and I do want to wire in the power feed setup to the mill supply so that when I kill the power to the mill, it kills the power feed as well. I do want to be able to use the power feeds without the spindle running. Where are we? I haven't got the mill switched on. Yeah, I do want to be able to gauge the power feed without the spindle running, so when I switch off I want the power to the feed to continue. That'll be useful for clocking things up and what have you. But what I do want to do is tap into the e-stop. I may need to put a relay in the control box down below that perhaps kills, I probably won't use, I'll probably use it to kill the power supply completely to the unit. So when the e-stop is pushed up here, it'll make a relay down inside my control box, which will kill the 240 volt completely. Or maybe I'll put it into the 24 volt line, so that it kills the 24 volt supply. Again, I don't know how immediate that would stop it. The enable line stops it immediately. I may rig it into the enable line on the relay, use a multi-poled relay, a little plug-in relay, so that when you push the e-stop, the relay coil makes the relay, kills the 24 volt supply to the power feed, and makes the enable at the same time. So if the 24 volt current takes a while to drop off, it's going to stop immediately because I've killed the enable and the 24 volt. So yeah, that's something worth looking into. I'll have to try that and see how immediate it is if I just use it to kill the 24 volt. I think that might be the way forward. And if just killing the 24 volt doesn't stop stop the motor quick enough, because you get that drop in voltage from the power supply. I might find that I can actually make the enable line at the same time. It'll sort of double hit, kill it in 2 ways, kill the power feed in 2 ways. So yeah, that was suggested to me to run it through the e-stop. I think that's a good idea. Your normal protocol, if something's going to crash all the rest, whack the e-stop. Okay, it will stop the spindle, but if the table's still going, you want that dead as well with one point of control. So yes, I will be rigging that up. So happy days. Well, I think that's about it for this one, guys. As you all know, in Wales here, we're just finished week 1 of a 2-week lockdown with the old COVID situation. We've had a sort of second spike, and we're trying here to do our best to, reduce that risk by having a 2-week fire break or circuit breaker or whatever they're going to call it. Boris has just announced that they're going to do, I think it's from Thursday this week coming, they're going to do a 1-month lockdown for England. I don't know whether Wales is going to extend this 2-week one or not to follow suit. Hopefully not. But the situation in Wales isn't quite as bad as it is in some areas of England. But some areas of Wales, the sort of Cardiff area, Merthyr areas and what have you, have had quite a second surge of this COVID. Here in Pembrokeshire, it's very, very few indeed. So that's good news, but at least we're shut down for another fortnight, and or for another week from now when I'm filming this, and hopefully it's going to save a lot of lives. So wherever you are in the world, take care, wash your hands, wear your mask, social contact, keep 2 meters away, all the rest of it. It's been a funny old year, hasn't it, guys? But, hopefully if everybody follows the rules and everybody takes care and does what they're supposed to do, we can get an end to this sooner rather than later. So moving on, I'm going to put a link in the description below to all the bits and bobs that we've used or that I bought. It's pretty much all eBay. The switches, the stepper controllers, the motors, everything like that. Obviously wire and what have you. You can source your own. It's not complicated. But yeah, the belts and pulleys and all the bits I've used that I know work. At least you can, if you want to do something similar yourself, or whether you're going to use Arduino control or something like that. But the basic parts are the same. Anyway, thanks for watching, guys. Thanks for subscribing. And we'll see you all very soon when we're going to get on and machine the aluminium for the Z-axis. Cheers now.